Myself Aditya Hariprasad Bandi and Internet emertex information technologies doing IoT internship. We shall see the learning outcomes, basics of C, basics of C++, embedded system and IoT, and mini project. First of all, basics of C, data types, integral, integer and character and floating point, float and double, qualifiers, constant and volatile, conditional constructs, single iteration and multi-iteration. In single iteration, if and its family, switch, etc. In multi-iteration, for, while, do while, etc. Operations and their persistence, logical assignment and bitwise. Arrays of C. Arrays store multiple values of the same point. Pointers store memory addresses. Strings are characters array, string slicing, string manipulation. Storage classes like auto, static, define variable scope and lifetime. Header files, they organize function and macro declaration. Basics of C++. C versus C++. C uses POP concept whereas C++ uses OOPS concept. OOPS concept is very different from POP, procedure oriented programming, while OOPS is object oriented programming. In the main OOPS concept is actually building blocks of C++, class, objects of C, access, modifiers, constructors and deconstructors. Pillars of OOPS: encapsulation, abstraction, inheritance and polymorphism. Virtual functions of C++: static linkage, dynamic linkage, and runtime polymorphism. Whereas C++ features are object-oriented programming, popular, case-sensitive, machine-independent, existence of library, simple, compiled based speed, dynamic memory allocation, high-level language. Templates helps to write generic programs, types, function template and class template. Exception handling. Exception is a problem that arises during exception of a program. Works on three keywords: try, catch, and throw. The third one, Internet of Things, that is IoT. Here, unique objects are connected to Internet. As an example, a mobile phone along with a TV, etc. And here, devices are connected, not human beings. It is a bidirectional communication and it can be handled from anywhere in the world. It for handling the bidirectional communication, you only need internet. That is all. It is a large, complex data flow service which can be occurred at anywhere. New types of insights. 3.2, that is embedded system. Combination of hardware and software which is intended to do a specific task. Example, washing machine, TV and smart watches. Categories of embedded system based on performance and functional requirements: real-time, standalone, network or mobile. Based on performance of the microcontroller, small scale, medium scale, sophisticated. Based on the performance of functional requirements, real-time, completes task within a given deadline. If deadline missed, it is hard real-time and soft real-time, firm real-time, etc. Second one, standalone, follows instruction blindly, takes a decision on its own without human intervention. Third one, networked, helps in getting connected, example router. Fourth one, mobile, embedded system, that is movable, designed for smartphones. Components of embedded systems, microcontrollers, microprocessors to process the code, memory, RAM, SRAM and DRAM. For ROM, PROM and EPROM and masked ROM. Sensors, analog and digital. Actuators convert electrical energy to mechanical energy. Human interfaces for switches only. Diagnostic port monitors embedded system. Auxiliary system to cool the device. Some basics programs that we have been taught in our internship course: to toggle an LED, to print hello on the CLCD in first line using different softwares, to read value from a temperature sensor and display it on the CLCD, to test analog write function, to control brightness of LED with LDR sensor, to control the inlet valve and the outlet valve of the water tank. Home automation project. It is a type of mini project we have been done in our internship course. Software used, that is Arduino IDE, PiximLab and Blink IoT. Whereas you can see that this is PiximLab software, and in which PiximLab it is Arduino board. Arduino board is a microcontroller in which we actually code and do things that are related to embedded system. And if we do external internet, then it can also used using Blink app. Whereas Arduino IDE is a software where we actually code, we write the code and we fed the code in the Arduino Uno board and many different Arduino boards. PiximLab simulator used to execute the code. That is a virtual software where we can get virtual sensors, and all the sensors and boards are workable. Blink IoT, it can control hardware remotely, it can display sensor data, it can store data, visualize it. Blink IoT is not only a software where we can also store real-time data using cloud infrastructure and cloud technology, where we can display real-time data through it. First mini project, garden lights control system. A garden lights control system automates outdoor lighting based on ambient condition, time, or user input. It enhances energy efficiency, safety, and aestheticism in public or private green spaces. Read the LDR sensor value and vary the brightness of the LED accordingly, which resembles controlling garden lights based on the availability of the sunlight. First one, we can see that these are the LEDs which are on, and I have connected these LEDs to the Arduino board. This is the LDR sensor, this is the Arduino board. If I decrease the LDR sensor, then these LEDs value will also glow down. The intensity of the LEDs glows down. Second one, temperature control system. A temperature control system automatically monitors and adjusts the temperature of an environment or device to maintain it within a desired range. It's widely used in industrial automation, agriculture, and smart homes. Third one, cooler controlled system. A cooler controlled system automatically regulates temperature by activating cooling devices like fans, pumps, or air coolers. When the environment gets too hot, it's used in homes, greenhouses, server rooms, and civic spaces to maintain comfort and prevent overheating. Detect the change in the logic level. If the bottom widget is at logic high, turn on the cooler. If the bottom widget is at logic low, turn off the cooler. Fourth one, heater control system. A heater control system automatically regulates temperature by activating a heating device which the environment gets too cold. It ensures comfort, safety, and energy efficiency in homes, labs, and industrial setups. Detects the change in the logic level if the button widget is at logic level high, turn on the heater. If the button widget is at logic level low, turn off the heater. We can see that the temperature is rising. The ambient temperature is 29 degrees Celsius, whereas the temperature rise is at 75 degrees Celsius. Fifth one, threshold temperature control system. A threshold temperature control system is designed to monitor temperature and trigger actions when it crosses predefined limits. It's widely used in smart homes, greenhouses, industrial automation, and public infrastructure. Turn off the heater if temperature exceeds 35 degrees Celsius. Whereas the sixth one is volume of water. Displaying the volume of water in water tank on the CLCD. Inlet valve control. If the bottom widget is at logic level high, turn on the inlet valve, and if it is at logic low, turn off the inlet valve by sending command through serial communication. Inlet valve control, same as the in outlet valve control, is same as the inlet valve control. Control the volume of the water in the tank. If the volume of the water in the tank is less than 200 liters, turn on the inlet valve and send notification. This was the we shall further see the mini projects, working projects.
We can see that the tank is getting filled by water. It is connected to COM port 4. This is the Arduino Uno board. This is the main code I have written. The tank is getting drained out.
Fan is rotating. We can turn off the fan and we can turn on the fan. Here we can see that heater is on, and here when I turn off, you can see that heater is off. And yes, this is my mobile screen.
The fan is on. As soon as we decrease the LM35 reading, the LED get on and temperature increases. As we turn on the LM35 reading, the temperature decreases and becomes normal. Here the temperature again decreases and again gets normal.
Uh, this is my personal project named parking intimator. This is my code I have written, and here actually I am going to firstly compile export compiled binary. It is done compiled. We shall save it. We shall open Pixim Lab. We shall open file. We shall load X file. It is 12. Okay. Uh, Here we can see that remaining four cars are there. Past zero cars means zero cars have passed and four slots are there for parking. As one car enters, the barricade will get open. As the car passes through the next ultrasonic sensor, the barricade will get closed. And we can see that the count is decreased from 4 to 1. As soon as the car passes through barricade 1, the barricade 1 will again get open. When the car passes through second IR's ultrasonic sensor, the barricade will get closed and the count goes on decreasing. Thank you.